Good morning. We're skipping section 6.3 because that's called integration by parts. That's a Calc 2 topic. It's beyond the scope of this class. So we're going to jump up to a really important one, 6.4, more solving of differential equations. However, today's a big deal because they are going to be separable differential equations. And I can tell you, with the exception of last year, because it was off year, they didn't do this. This has been a free response question, almost guaranteed, every year for probably the past 5, 6 years they've been on there, okay? So we need to think about a differential equation. What is it? Well, it's really just a derivative equation. And we solved them kind of 3 different ways, right? First of all, we graphically solved them with a slope field. And just out of the, I'm not going to solve all this just to save some time on the video, but this whole differential equation right here, that whole thing depends on x. So it takes me an x to get my dy dx, to get my slope. So I'm like, oh, okay, well, if x is 0, well, my slope is 0. So that means everywhere x is 0, I have this going on, okay? And you might be able to look at this differential equation and know, ooh, I know what it is. I know what it is. It's a parabola, okay? So if x is 1, well, then y is 1. So then I just come over here and I just try to aim and make a slope of 1 on all of these at 1 because they're all the same. And if x is 2, well, then y is 2. So the next one is just a little bit steeper, so I aim with a slope of 2, and I just try to make these get parallel. And then if it's 3, it's 3. Okay, well, that just means as x is getting bigger, y is getting, my slope is getting steeper. And when I'm over there on the negative side, well, how about a -1? Oh, my slope's -1. So these are all aiming, and I'm just aiming for a slope of 1 with those. And then the next one's kind of 2, so I aim at a 2 on these. And it goes up, and then the next one's a 3, so I'm kind of aiming 1, 2, 3. I'm aiming more steep there. And bottom line, I can get a picture of this. And you stand back, and it's like that. It's like jumps up. Whoa! I see you. You're a parabola. And if I had to graph it with the initial condition of when x is -2, y is -1, well, that's just making me come in here and plot this point, -1, -2, right here. And I just need to make sure, as I'm sketching, I can see it's a parabola. As I'm sketching, I'm getting flatter, and then I get that. And as I'm coming through these regions, my slope is kind of parallel with all of those, and then it's going to get steeper, and it's going to get steeper, and it's going to kind of come up. In the same way as I come through here, my slope is going to be parallel, and it's going to get steep. And what it's a graphical solution. It's giving me a picture of y. It's not giving me what y is. Well, we can do this in our calculator 2 ways with technology as well. Well, if you forgot, this I will run through it. We can graph this slope field in our calculator by graphing our calculator. If I add a page and I add a graph page, well, remember we're in function mode here, so we need to edit our graph. We're editing a number 8, a differential equation. My differential equation, dy dx, remember that's just another way to say y prime, which is on there. Y prime equals x. And when I do that, I hit enter, boom, there's my slope field. It's kind of what I created, but a lot more points. And on here, if I toggle up, I can hit tab, and I can hit my particular solution of -2, -1, okay? And what it's going to do is it's going to graph it. And if I wanted multiple ones, I would hit that little plus thing there, but I'm going to hit enter. Boom, there it is. Okay, so I can get the picture graph of that little bugger. Let's see if I can do this. If I'm very good, I'm going to capture that page. And go on my notebook. I'm going to come over here and see if I can paste that little bugger. Hey, I'm finally getting a little bit better at this. And what I'm doing is my picture, hey, Kirby, you did kind of okay on that graph off the slope field. And your calculator, that CASA, it's a powerful piece of equipment, man, I'm telling you what. It will also, if you add your calculator page, it will also algebraically find this thing. Now, before I do this, because I'm going to come into mine, I'm going to hit menu. You're going to want to hit menu. You're going to want to hit calculus. And you're going to want to toggle down until you find your differential equation solver, which is D. It's a menu for D. But you hit enter, and mine looks different than yours does, okay? And what yours is going to look like, just hang on here a second. It's going to look a little different. I have to hit this in here. I got to say, and you're going to have to type this. So if you did menu for D, I'm going to try to tag team this at the same time. Switching gears. If you did that, your calculator says DSolve with a parenthesis, okay? You want to type in exactly what I'm typing in this next line. You want to type in y prime equals 8. Ooh, no, it doesn't equal 8. You want to hit, wow. You want to hit y prime equals x. We want to type in our differential equation. So I'm going to come over here. It's just a little bit easier in mine. I got to hit y. And your prime button is over here by the pi. If you hit your pi key, it's right there. It's that little guy. Hit y prime equals x. And then I'm going to hit tab. And then mine asks me independent variable dependent. Well, I know my independent variable is x. Tab, I know my dependent variable is y. And I can put an initial condition in here. And I will in a minute, but you don't want to do your independent, because if we're putting in our whole solver, okay, you are now at this point, and you want to type in yours, okay, you want to hit a space, one space, then you want to type AND, and then you want another space, and this is for our particular solution. Then inside that, you're going to type in function form y of -2 equals -1, and then you have to do a comma x for your independent variable, comma y for your dependent variable, and close your parenthesis. And then that's how you finish yours up. Mine's a little bit easier because I have the newer processing system on here, and I'm going to say my initial condition, tab, my initial condition is y of -2 equals -1, I think is how I put mine in. And I'm going to hit enter and see what you have. Mine just automatically organizes it, and you go right into there. You close your parenthesis, you hit enter, and it tells you, oh, it's x squared over 2, or it's 1/2 x squared minus 3. And now remember, you have, when you type this in, you have a space here and you have a space here. Otherwise, no other spaces. So I'm going to try to see if I can capture this little bugger, and I'm going to see if I can come back to my notebook. That way you can come back to this and say, hey, I see how you did that. And I'm going to edit. I'm going to try to paste that. There it is. And I'm going to get that guy in here too. And I'm going to grab him. I'm going to pull him down right on the DSolver, and it's going to give you your answer right there. Okay, so that's two ways to do it with your technology, with slope field or in solver. Next, we're coming along, we're going to get the algebraic solution. Well, we did this in 6.1, I think it's 6.1, and we did this, okay, with an initial condition. We're like, hey, this is without separation of variables, but this is a differential equation that you know how to solve, okay? But as I move on, we're going to be running into, I don't know how to do those. Those look really hard. No, they're not. You just got to trust the process and work at this, and it's a piece of cake. So what did we do? We solved our differential equation. This is without separation of variables. And again, you know how to do this already, because you know the antiderivative of dy dx. You know that's y. And you know the antiderivative of x. Well, that x to the first came from an x squared, right? And then I had a coefficient of a 1, so that's a half. O plus c. Because we don't know what that constant is, then we have to find that constant with this x and this y, remember. Well, then we come back, oh yeah, I can find that. Negative 1 equals 1/2 negative 2 squared plus c. Well, that's negative 1 equals, well, that's 4 times 1/2, that's 2 plus c. C is negative 3. So my particular, this is my general solution, but my particular solution that goes through that point is going to be y equals 1/2 x squared minus 3. That is the particular solution of that differential equation, okay? And, well, I guess we're going to have to talk about separating variables now. We don't need to on this problem. However, we will be separating variables, and just so you know, as I do a couple examples today and on Monday, I will only be moving things from one side of the equation to the other. The only way I will be doing it is utilizing multiplication or division. I will not be adding or subtracting. I will multiply or divide only, just so you know. Well, what are you talking about separating the variables? Well, when I do separation of variables, what I typically want to do is I want to move all the y's to the left side of the equation and all the x's to the right side of the equation, okay? And then I'm going to separate and integrate. I'm going to hit pause. I'm going to write that on the screen so I don't take more of your time here. Okay, so like I said, when I'm doing integration by separating the variables, this will be a problem on your AP test. And if you don't separate, you basically, you're stick a fork in there, you're pretty much done on that problem. But separate means move all the y's to the left side of the equation and all x's to the right side of the equation, only using multiplication and division. Once I do that, I'm going to integrate both sides. This is going to give me my general solution. After I find the general solution, I will use my initial condition to find the particular solution. So I'm going to separate and then integrate every time. What do you mean? Well, I have x's and y's. I need my differential of x over with my x's when I separate. So I'm kind of like, oh, okay, I can multiply that guy over. Because this side they die on, I get a dy equals x times dx, okay? So I have separated my variables. After I separate them, I will integrate both sides. Oh, we're just looking at this a little bit different than we did before, okay? So what is the antiderivative of dy dx? That's 1 dy dx. Oh, that would be y, wouldn't it? Well, what's the antiderivative of x dx? Oh, let's back it up here, Kruger, because I already know a question's going to be, whoa, he didn't do that right. He didn't put his plus c. So I'm going to call that a c1, if you may. I'm only going to do this once, and then I'm never doing it again. And then that's going to equal, ooh, that's an x squared with a 1/2 plus, ooh, that's probably a different constant over there, because most likely they're not the same, right? But bottom line, if I subtract this c1 over here with this c1, I don't know what they are, but I do know it's gone from here, and I get y equals 1/2 x squared. I don't know what this is, but this is going to be my constant of integration, because I'm going to put those together. It doesn't matter what they are. So I am only going to ever add my constant of integration to the right side with my x's, never the left side. Always? Yes, always. Then I'm going to come back and I'm going to use my initial condition like I did before. I'm going to say -1 equals 1/2 -2 squared plus c. And all I'm doing, I'm doing the same thing, but now I'm separating the variables. See, I separated my x's and y's. This is -1 equals 2 plus c. Hey, check it out. C, it still equals -3. Found it on the calculator in the whole 9 yards. So y will equal 1/2 x squared minus 3. Okay? And the first step is the most important step. Are they going to make me separate something like this in the AP test? Absolutely not. Why? Because they're going to give you some more difficult ones than that. All right? If you remember, we did this one earlier in this year too. And if you remember, this was the derivative of a circle. This was half of a circle if we want it to be a function. All right? Remember, it's half of a circle. we can do this really easy in our calculator. Our calculator is going to do it. But I don't want to do that. I want you to know how to algebraically do it because that's what you're going to be tested on. So what do we have to do? We have to separate and then integrate. We need to get all of our x's on the right side with all the x's and all the y's on the left side with the y's, only using multiplication and division. Well, how am I going to do that? Well, I guess if my x's go on the right side, I need to move this dx over here. And guess what? You're going to do that move every time. That's going to happen every time. But now I need to get my y on the other side. Well, how am I going to do that? Well, y is in the denominator. So how about I just say, I'm going to take this side times y, and I'm going to take this side times y. What you do to one side, you do the other. Ooh, check it out. Now I have y dy equals negative x dx. I have separated them, and therefore I have the green light. That's why I did it in green. I have the green light to integrate. I have separated. I got all my x's on one side, all the y's on the other side. I'm going to separate, then I'm going to integrate. And that's what I just did. So what is the antiderivative of y dy? Well, that's y to the first power. So that had to come from a y squared, and there's a coefficient of a 1 on there. That had to have a half on it. That's going to equal, remember, I'm only going to add my plus c to the right side. Just not going to do it. And that's an x to the first, so that's going to be an x squared. And that's a negative 1 there, so that must be a negative 1/2 there, plus my constant of integration. Well, this is a tricky one now, okay? This is a tricky one. My initial condition is 2, 2. Remember, we said this is a circle, right? This whole thing is a circle, okay? But my initial condition, this circle is not a function, is it? Because it fails the vertical line test. That's why I started out and I said it's a half of a circle. So what half of the circle are we looking for? Well, if we are looking for 1, 2, 1, 2, if we're looking for, oh, I did a bad. If we're looking for over 2, up 2, I get that. I just don't even like those points I put on there. Come on, get out of there. Get out of there. If I'm looking for the initial condition over 2, up 2, and I'm looking for that point, well, that point would be on the upper half of the circle now, wouldn't it? So I'm going to get rid of that. So to be a function, I'm looking for the equation of that guy right there, which is the top half of the circle. Okay, why is that important? Yeah, you'll see, I hope. Okay? So, as I'm plugging and chugging, I got a 2, 2. Well, I still need to find my c value, don't I? So I'm going to use my 2, 2. I'm going to use my initial condition, and I'm going to plug that in. So I got 1/2 times 2 squared equals negative 1/2 times 2 squared plus c. Well, 2 squared is 4 times a half is 2 equals 4 times negative, that's negative 2 plus c. So c, what does c equal? This is telling me c equals 4. Okay, so now I have my equation of 1/2 y squared equals negative 1/2 x squared plus 4. Great. Now the last thing you have to do is you have to make sure it's solved for y. So you have to find c and then solve for y. Notice I didn't have to do that back here because this thing was solved for y already, because that's all I had on the left side. Over here I got more than y, more than just a y. So I need to solve for y. Well, how would I do that? Well, let's think. I don't like the fraction, so I'm going to kill that first. So that's going to give me a y squared equals a negative x squared plus 8. Okay, like it. And oh boy, y still isn't alone, is it? Y is not all by itself. I need to square root both sides now, don't I? That brings me into y equals, oh my goodness gracious me, and you can switch this and call it 8 minus x squared if you'd like. Okay. Now, ooh, that's a positive or an which half of the circle do I want? On the AP test, they don't want both because it's not a function. They only want one portion. My initial condition is on the positive half. The top half of this circle is 8 minus x squared. The bottom half of this circle down here, it's negative square root of 8 minus x squared. Okay, so that's why I need to know if I'm on the top half or the bottom half. So I need the top half, so I just get rid of that minus, and there it is. There is my function y, okay? That's it. Well, I have one here that's not in your notes. I'm going to add a page, okay? I'm just going to kind of throw one at you, and I'm going to say dy dx equals y. We looked at this slope field before. This was the trumpet that looked like it was blowing one way, and we figured out that it was an exponential function. Well, how? We don't know how to algebraically do this because I can't integrate the way it says. So let's make it happen. And we're going to give an initial condition. Initial condition of 0, 2. Okay, be a good one to have in your notes yet. So we know this is going to be an exponential function. Well, before, if you just start integrating right now on the AP test, you are done-so, okay? Because this is going to make it look like I can't integrate y without being on the side of dy. So what the heck am I going to do? Well, I got to separate. Told you multiplying by dx is the first step you're always going to do. Y times dx. I don't like that. I can't have that with that differential. So what am I going to do? I think it might be a good idea to divide by y or multiply by 1 over y. I really don't care what you do. I like to multiply by 1 over y, and that gets rid of that. I have now separated, and I get 1 over y dy equals dx. Well, isn't that fancy? I have my variables separated. What do I do next? That gives me the green light to integrate. I separate, then I integrate, okay? Ooh, boy, oh boy, oh boy. What is the antiderivative of 1 over y dy? Looks like an ln absolute value y, doesn't it? Equals, ooh, what's that? That's x plus c. Okay. I do have an initial condition of 0, 2. In the end, I need to find c and solve for y. In any order you want, you can find y, then you can solve for y, then find c. You can find c, then solve for y. Whatever you want to do. Okay? Me, personally, I usually always find c first unless I have a natural log in it. If I have a natural log in it, I always solve for y. Ooh, how do I extract that y out of the natural log? Well, remember, logs equal exponents. What do? We rewrite it. What's the base of an ln? It's an e. So this is e to the x plus c equals y. And really, it's the absolute value of y in there. However, I can drop my absolute value here because hopefully everybody's on board to say, e to a power has to be a positive number. It can't be negative. So I can drop my absolute values at that point in time. Oh boy, but now I got c up in the exponent. Well, here is where a fun little math trick comes from. It's nothing math trick about it, I shouldn't say. But check this out. When do you add exponents? You add exponents when you have common bases multiplied together. E to the x times e to the c is e to the x plus c. Oh, I'm taking my addition of exponents away. I'm kind of backing it up. Because what is e raised to the power of some constant? Because that's a constant. That c is a constant. I don't know what it is, but e to the c is a constant, isn't it? So that's going to be e to the x. It's going to be a constant. It's going to be a number times c equals y. So what happens with my natural log, this c up here that I'm adding, that little bugger turns out to be c e to the x equals y. And the fun part of it is, all your calculus professors, everybody, they're like, these people know their algebra rules fine. They hit right up here, they're boom, and you're like, how did that c get down there? Oh, my properties of exponents. Kruger showed me step by step. You will go from here to here very shortly. Well, now I know I got c e to the x equals y. I have solved for y, but I now need to find c, don't I? Well, check it out. Here's my initial condition. C, I don't know. E, it's 2.7 something, but I know x is 0 equals y is 2. E to the power of 0, that would be 1, so c has to equal 2. So what is it? My particular solution is going to be 2e to the x equals y. There is my particular solution. There's my particular exponential function that goes through that point. Woo! Got it? Okay? I'm going to do, I think, one more, and then I'm going to stop. I'm going to not amping it up at all, but I'm going to do number 2. Then I'm stopping for today, okay? And, here's one I have to separate. FYI, okay? If you can make it through the problem, meaning once you separate your variables, once you get to the separation portion here, you're usually a couple points in. If you can integrate after you separate, you're about 3 points in, okay? And then getting C, even if you can't find C, you're like plus 3-ish points just to get to this step right here. So that's why you always try and you keep going. You're going to find C in these exponentials the same way every time. Well, we got another one here. We're going to separate this dirty dog. Well, remember, you're going to get to the point where you're just going to zip things over and you're going to, yeah, but it's early. We're going to separate. Why did I put a 2 there? I don't know. Kind of dumb, losing the marbles. Times the dx, times the dx. They're gone. dy equals 2xy dx. Well, I need that y to get out of there. Well, if that y is in the numerator, I can think of dividing it out. And what is the point of this? Well, let me go inside. No, I'm not going to go inside. I'm going to keep running. I got to get rid of that y. So I think of 1 over y. 1 over y. Okay, and there's a reason why I think of that. I don't always do that, but I see this y cancels this, and I end up with 2x dx equals 1 over y dy. Why do I do that? Well, here's why. Because if I'm at dy equals 2xy dx, and I think of dividing by y, okay, what most students do is they get to this point, dy over y equals 2x dx, and then when they integrate, I've separated properly, but when they integrate, they're like, whoa, what's going on here? That's a natural log this time. It's in the denominator, okay? So that's why. It's the only reason I do that. And technically, yes, this is an ln, absolute value of y, plus c. It's one constant. Remember, should put my notation. I'm not going to put that c on there. And what happens is this side, that's an x squared. Ooh, that's a 2. That was nice. Plus, this is a c sub 2. And when this guy comes over here, well, it's really ln absolute value of y equals x squared plus yet another constant. But it doesn't matter what they are. You don't have to really label them C1, C2, C3. Okay? It's a constant. That's why I would leave that dirty pup off. And I wouldn't put a 2 on that because it's getting put with it anyways. And I would go straight to that, right where I was at, okay? And then I'm like, okay, well, you can solve for C, or solve for y, then find C, or solve for C and then find y. Well, which order should I do it in, Mr. Kruger? Yes, whatever order you want. Here is Kruger's philosophy. And, you know, every time I say it's my philosophy, I'll break it. But when I have one of these guys in there, I will always unconditionally act. I will always solve for y first because that c is going to come out. I don't have to. I just feel the algebra is easier when I do that. So how do I solve for y? Well, remember, this is ln is a base e exponential function. How do we get that out of there? Well, logs equal exponent. Let's rewrite our function Lasso-S style. E to the exponent equals absolute value of y. No, I do not need the absolute value of y because e raised to the x squared plus c will always unconditionally be positive. Okay? Well, why do I have to have it in the step before? Because if you don't, they're going to knock you points. That's why. Hate to put it that way, but then I'm going to show you this another time here. Okay? So then when I'm solving for y, remember this is because these because there's addition in the exponent, that's really e to the x squared times e to the c, where this just equals a number. So we're going to hyperlink down, and we're going to say, ooh, this is one big old fat constant times e raised to the x. So I'm going to say this is really going to go c e to the x squared equals y. Okay? So I have solved for y. Then I'm going to take my initial condition of 0, 3. And I'm going to use that initial condition to find my c. And 3e x to the 0 squared times c. So this is c equals 3. Does it always work? Well, not always, but c is 3. Therefore, my function y equals 3e to the x squared. That is my exponential function after I separated my variables. And you know what? You make it that deep in the problem, they're going to make you use it. But 9 times out of 10, you're 5, 6 out of the 10 points already. And it's really, I hate to say it, it's kind of simple algebra, okay? And so from there, you don't have any assignment tonight. You can start it if you want it, but we'll finish this one up the next day, which is this year is going to be on Monday. So, hey, thanks for playing math. I hope this makes sense. Just remember, when you're getting a differential equation in terms of both x and y, when you solve it, you want to separate, then integrate. And after you integrate, then you have to solve for c. You have to find c and solve for y in either order you want. Hey, have a good night, guys. Have a good one.